Welcome to the lecture number 2 of inverse Laplace transform. In previous lecture, we have started the inverse Laplace transform. In that, we have seen some basic formulas of the inverse Laplace transform, and also we have solved some numericals on examples on basic formula. Okay, so let us see some more examples, and after that we will start the next type. Okay, so let us take an example number 6. Find Laplace inverse of s upon s square plus 9 plus 1 upon s square plus 16. Okay, so now how to simplify this example? Laplace inverse of s upon s square plus 9. Okay, we can separate it. Laplace inverse of 1 upon s square plus 16 bracket close, that is equal to, now what is this formula? Laplace inverse of s upon s square plus this 9 can be written as 3 square plus Laplace inverse of 1 upon s square plus this can be written as 4 square. Okay, now that is equal to, this can be written as cos of 3t, this is Laplace inverse of cos 3t, plus what is this? This here we have to take 1 by 4 into sine of 4t. Okay, so this is value of f of t. Okay, very simple, right? Now let us take another example, example number 7. Find Laplace inverse of two s plus 5 upon s square plus 25. Let us consider this example. Then how to do this? Here this is very simple example. What we have to do here? Laplace inverse of, just separate it, 2s upon s square plus 25 plus 5 upon s square plus 25. Okay, and if you solve this further, Laplace inverse of s upon s square plus 25, this 2 is common, plus Laplace inverse of this 5 we can take common here. Okay, and this will be 1 upon s square plus 5 square. Now this is equal to 2 into, what is this? This is cos of 5t plus this will be equal to, okay, if you keep this 5 as it is here, this is nothing but sine of 5t. So no need to modify. Okay, so this is the Laplace transform, right? Let us take another example, example number 8. Find Laplace inverse of 1 upon s raised to 5 by 2 plus 1 upon s raised to 4. Okay, so how to simplify this? So Laplace inverse of 1 upon s raised to 5 by 2 plus Laplace inverse of 1 upon s raised to 4, that is equal to, now by using formula, what we can write this? T raised to 5 by 2 minus 1 upon gamma 5 by 2 plus here t raised to 4 minus 1, that is, okay, 4 minus 1 upon 4 minus 1 factorial. Okay, and if you simplify this further, what we get here? So this can be written as t raised to 3 by 2 divided by gamma, this 5 by 2 can be written as 3 by 2 plus 1, and here t raised to 3 upon 3 factorial. Okay, now that is equal to, again if you simplify further this, what we get? That is equal to t raised to 3 by 2 divided by 3 by 2 gamma 3 by 2 plus t raised to 3 upon 3 factorial is 6, and that is equal to t raised to 3 by 2 upon 3 by 2 into gamma, this 3 by 2 again can be written as 1 gamma 1 by 2 plus 1 plus t raised to 3 upon 6, that is equal to t raised to 3 by 2 upon 3 by 2 into this again 1 by 2 gamma 1 by 2 plus t raised to 6 upon 3 upon 6, t raised to 3 by 2 upon 3 2 2s are 4 and this will be root pi plus t raised to 3 upon 6, that is equal to, this 4 can be taken at numerator, so t raised to 3 by 2 upon 3 into root pi plus t raised to 3 upon 6. Okay, so this is what value of f of t. So in this way we can solve the numericals depending on the type number, that is depending on the basic formulas of the Laplace inverse transform. Okay, so now let us take some examples for homework. You try to solve these examples. First example, find Laplace inverse of s upon s square minus 8 minus 2 upon s square minus 9. Okay, example number 1. Example number 10, find Laplace inverse of 3s plus 4 upon s square minus 10. Next, find Laplace inverse of s square plus 2 bracket square upon s raised to 6. Okay, so you try to solve these examples. Now let us start with the next property, that is properties of inverse Laplace transform. Properties of inverse Laplace transform. Okay, so in that first property number 1, that is first shifting property. Now what is this first shifting property? Let us see. So we know that in Laplace transform we have seen the first shifting property. So Laplace transform, let us see the basic of this first Laplace transform. If Laplace transform of f of t is equal to f of s, then Laplace transform of e raised to at into f of t is equal to f of s minus a. Okay, this we have studied. Laplace transform of e raised to minus at into f of t is equal to f of s plus a. This also we have studied. Okay, so this is the basic of the Laplace transform, right? This is the basic of the Laplace transform. Now from this basic we can derive the first shifting property in the inverse Laplace transform as follows. If Laplace inverse of f of s is equal to f of t, then Laplace inverse of f of s minus a, that is this. Okay, Laplace inverse of this will be this value. So e raised to at into f of t, and Laplace inverse of f of s plus a, that is this, that is equal to, answer is e raised to minus at into f of t. Okay, and this is the first shifting, this is known as first shifting property. Okay, now let us try to solve some numericals depending on this particular property. So example number 1, find Laplace inverse of 1 upon s minus a bracket square plus b square. Okay, a very simple question. Now if you observe this question, you will find that here wherever there is value of s, so there is s minus a in this particular example. So here by using first shifting property, we can write, first of all we have to take this minus a outside. So e raised to at, if there is minus, here we have to take positive. Okay, so that minus plus a minus a is we have written in the form of e raised to at. Now what is remaining here? 1 upon s square plus b square. Okay, now that is equal to e raised to at into what is Laplace transform of 1 upon a square plus b square? So this is very simple, 1 upon b into sine of bt, and if you further simplify this, okay, you can write this in the standard form. So that is equal to e raised to at into sine of bt upon b, and this is your final answer. Okay, so it is very, very simple, isn't it? So now let us take another example. So the example number 2, find Laplace transform of 1 upon s plus 5 raised to 4. Okay, find Laplace inverse of 1 upon s plus 5 raised to 4. Now if you observe this, what we can say that, so here there is s plus 5, and therefore by using directly first shifting property, this can be written as Laplace inverse of 1 upon s plus 5 raised to 4 can be written as, so we have to take this plus 5 outside, so e raised to minus 5t into Laplace inverse of 1 upon s raised to 4. Okay, now that is equal to e raised to minus 5t into what is Laplace inverse of 1 upon s raised to 4? T raised to 3 upon 3 factorial. And finally this can be written as e raised to minus 5t into t raised to 3 upon 6. And this is the answer. Is it? Okay, it is very, very simple. Now let us take another example. Example number 3. Find Laplace inverse of s upon s plus 2 raised to 4 plus 9. Sorry, not 4, here we have to take it 2, s upon s plus 2 bracket square plus 9. Okay, now how to simplify this question, let us see. So Laplace inverse of given s upon s plus 2 bracket square plus 9. Now if you observe this question, here at the denominator there is s plus 2, but at numerator there is no s plus 2. So first of all we have to adjust s plus 2 in the numerator also. So how to adjust it? So you directly write down s plus 2. So we have taken here extra plus 2, so take it minus 2. So s plus 2 bracket square plus 9. Now if you observe this, so there is, here is also s plus 2 and here is also s plus 2.